Dr. Devi. Today we are going to see about the topic of cyclic voltametry. Nowadays, researchers most focused on the topic of electrochemical sectors like fuels, batteries in the applications. So for these applications, the most widely used technique is the cyclic voltametric technique. So cyclic voltametric technique is nothing but one of the voltametric technique. It is used in it is a type of electrochemical method. So in this method, it is used to study the redox behavior of chemical compounds. So when the current is produced on the electrochemical cells, so when the voltage is applied. So for that purpose, when the basic principle of the cyclic voltametry technique is so when we are sweeping the potential between these two electrodes, the current is measured for the chemical compounds. So in this study of cyclic voltametry, it is used to study so many compounds, redox behavior, electrode kinetics and the surface reaction of the electrodes. So this is the basic principle of cyclic voltametry. In the voltametric techniques, when we are applying the potential between the two electrodes of working electrode and the reference electrode versus time. So in this, based on the applying potential, the current is measured for the some reduction component of its chemical substances. So when the potential is forward, it is the oxidation potential. When the potential is reverse, it is the reduction potentials. The current measured for this particular potential is known as the oxidation and reduction current. So when we are constant sweepingly applying the potential, some current is measured by cyclic voltametry technique. So for this cyclic voltametric technique, some electrochemical basic components are needed. So for the study of cyclic voltametry, the basic necessity of the study is the 3 electrode system. The first one is the working electrode, the second one is the reference electrode, and third one is the counter electrode. So in the working electrode, the study of the chemical substances known to be applied on the electrode surface and the current is measured. So in the reference electrode, a constant reference potential is measured. So in the counter electrode purpose to complete the circuit. Without the counter electrode, it is a 2 electrode system. For the usage of 2 electrode system, it comes along with the ohmic drop, IR drop resistance and lot of issues comes with the 2 electrode systems. For avoiding the 2 electrode system problems, we are coming for the 3 electrodes. We are using the counter electrodes. So the commonly used working electrodes are glassy carbon electrode, gold electrode and platinum electrodes. So these electrodes are inert and should not involved in the reactions and must be inert in the whole reactions. So for the reference electrodes, the first primary commonly reference electrode is the hydrogen electrodes, but hydrogen electrode gives a lot of problems. For this, avoid of usage of hydrogen evolutions. Some common reference electrodes are be used. So there are silver chloride electrode, calomel electrodes, because these electrodes should be in equilibrium with the chemical reaction systems. So normally the counter electrode is the process to complete the circuit. So mainly the commonly used counter electrode is the platinum electrode or platinum wire or platinum S. So for the sensor studies and batteries, they are using normally the platinum wire. For particularly in the platinum for battery studies, the platinum mesh wire is used because we are enlarging the surface area of the counter electrode. The current should be enhanced. So another most important thing is the electrolyte, because the electrolyte only is the current carrier between the electrode and the chemical substances. So it supports the medium for the conduction of ions between the electrode and the electrolyte. So when we are applying the potential, the ions moves through the electrolyte and reach to the electrode surface, and we are obtaining the current. So electrolyte acts as the medium between the electrolyte and the analyte. So the electrolyte must be highly conductive and it is non-reactive in the chemical reactions. Mostly in the cases supporting electrolyte is used for the chemical reactions. So this is the cyclic voltametric graph. So it will be obtained as in the x-axis it represents the potential and y-axis it represents the current. So this is the duck shaped curve. So when we are applying the potential, the current will be increases. So X-axis here it represents the potential and y-axis represents the current or current density. If it is the current density means the current is divided by the surface area of the electrodes. So the point at which the potential it has the maximum current is known as oxidation potential or reduction potential. The current obtained in the oxidation peak potential is called oxidation current, or the current obtained in the reduction potential or reverse potential it is called the reduction current. Sometimes the oxidation current is known as anodic current and it is reverse cathodic current is noted as the reduction current, IPA or IPC. So from the cyclic voltameter graph we are obtaining some information. So the most basic information about the reduction behavior of the electrode, and the second one importantly electrode kinetics of the system. So it calculate the number of electrodes involved in the system, and the third one is the peak current represents the concentration of the electrolyte. So if the peak separation represents means how the system is reversible or non-reversible and quasi-reversible, the peak shaped represents. So number of electrons means if the substance involved in the reactions, whether it may be 1 or 2 or half of the electrons involved in the reaction is calculated using this cyclic voltametric graph. So if the reversible peak means if the peak separation area is calculated by using EPA minus EA, so it will be E0 will be obtained. So the E0 value is 59 millivolt, means it indicates the follower the Nernstian equation and it having the highly reversible nature. So if it is higher than the 59 millivolt means it is the irreversible behavior, whether it have obtained only one peak or neither, it may be obtained sometimes quasi-reversible peak also obtained. Quasi-reversible means the peak area of E0 is very high. So from the separation of the graph we are obtaining the reversible, irreversible or quasi-reversible peak of the electrode systems. So this is the equation for the calculation of surface area of the electrodes by using the Randus-Sedgwick equation. So IP is equal to 2.69 into 10 power 5 N 3 by 2 A D half C under nu half. So from this graph we have to calculate the A. So we know the value of IP, that is the current intensity obtained from the graph. N is the number of electrons, so we are knowing that number of electrons involved in the system. D is the diffusion coefficient, concentration we are knowing that. So scan rate is there, we are applying some potential at the sweep rate, we are knowing that. So from the knowing parameters A can be calculated by using this formula. So this is the useful technique for studying the electrode kinetics, surface coverage area of the electrodes. So this cyclic voltametric technique is mostly used in the sensor studies and batteries and applications. So from the graph we have to study the stability of the compound also. Thank you.